Question in this video is how do we solve complex circuits? So we already learned about how we solve series and parallel circuits. The idea in this video is how do we now solve a circuit that has a combination of both series and parallel circuits. So if you don't remember how to solve series and complex circuit or series and parallel circuits, make sure you go back and rewatch those videos. Now in this circuit here we have a 9-volt battery. It's connected to 4 different resistors, 2 ohms, 5 ohms, another 2 ohm, and a 3 ohm resistor. The first thing we got to do is we have to combine resistors that are series or parallel until we can get them all in series or we get all the resistors in parallel. We know that 2 resistors are in series if they are next to each other with only wire in between. There cannot be a junction. There can be no split in the wire in between them. We know they're in parallel if they are connected on both sides with nothing in between. Now in a series, I do want to go back and point out that it could be a bent wire as long as there's no other wire branching off. There's only one path. Now if we look here, the only 2 resistors that are neither series or parallel are resistors 3 and 4. They're in series because there's nothing in between but a straight wire. There is no branching off of a junction or other wire. Some might want to say that 2 and 3 are in parallel, but the problem with that is although this side touches each other, the other side does not. There's another resistor in between. So in order to be parallel, there cannot be another resistor in an individual branch of that circuit. Okay. So what we're going to do first is we're going to combine these 2 resistors. We're going to combine resistor 3 and 4 together to make a single resistor. And to combine them, they are in series. So the combined resistance, we just add them together, and we get 5 ohms. So we're going to replace these 2 with a single 5 ohm resistor. We're going to redraw this circuit. We have our 9-volt battery. We have this resistor up here, resistor 1, which is still 2 ohms. We want to make sure that we draw this circuit large enough so we can write all of the information we need to on the circuit. This is still 5 ohms, that has not changed. And now we replace those 2 with a single resistor, we said, that is also 5 ohms. Now we still have a complex circuit. These resistors still are not all in series or all in parallel. But now what we can do is we can combine both 5 ohm resistors because they are in parallel. We know they're in parallel because both sides touch with only wire in between. Now to solve for the equivalent resistance of 2 in parallel, we add up their inverses. If I add 1/5 plus 1/5, I get 0.4. But that's not my equivalent resistance of those 2. I have to take the inverse of that, and I get 2.5. So I'm going to replace these 2 resistors with a single resistor that is 2.5 ohms. So I'm going to again redraw this. The key is to redraw because you're going to have to work backwards. If you skip out on redrawing things, it's going to be much more complicated for you to go backwards then. So we have our 9-volt battery. This resistor has never changed. It's still 2 ohms. And remember, we replaced those 2 in parallel with a single 2.5 ohm resistor. Now this is something that we've done in the past. There are 2 resistors and they're in series with each other. So what we're going to do is we're going to solve this entire circuit here, just like we had done with series circuits in the past. It is a series circuit, so to get the equivalent resistance, we simply add the 2 resistors together. 2 plus 2.5 gives us 4.5, and that is our equivalent resistance as seen by the battery. So the battery sees a total resistance of 4.5 ohms when all those other resistors are in place. Now once we know 2 out of the 3, we're going to solve for the third using Ohm's law. So I'm going to do some little scratch work here. V is 9. We're solving for I, and the resistance is 4.5. This gives me a current of 2 amperes. So the battery has a total resistance of 4.5 ohms and a current supplied of 2 amperes. Now in a series circuit, it is the currents, the I's, that are the same. So this current by the battery is 2 amperes. That means all the currents are 2 amperes as well. And again, once you know 2 out of the 3 values, we solve for the third using Ohm's law. So I'll do some scratch work here. We know that the voltage is the current, which is 2, times the resistance, which is 2, and that gives us 4 volts. Do some scratch work here as well. The voltage, we have the current as 2, and the resistance is 2.5. That gives us a voltage of 5 volts. Now what we're going to do is we're going to work backwards. Now nothing has changed about the battery. The battery is still 4.5 ohms and 2 amperes. So we work back to the first picture we redrew. This is still 4.5 ohms and 2 amperes. Nothing has changed about this resistor. It is still 2 amperes and 4 volts. So nothing has changed there. Here's the difference. This resistor here, the single resistance, is going to split into 2 that are in parallel. Now in a parallel circuit, it is the voltages that are the same. Here my voltage is 5 volts. That means now that the voltage of these 2 are both 5 volts. So again, in a parallel circuit, the voltages are the same. So the voltage when they're combined is the same as the voltage when they are separate, if they separate back into parallel resistors. Now once we know 2 out of the 3, we're going to solve for the third using Ohm's law. So I'll do some scratch work here. I've got 5 volts is equal to my current times 5 ohms. And that comes out then to be 1 ampere. And this is the same calculation. 5 volts equals my current times 5 ohms. And that gives me a current of 1 ampere. Now we're not quite done yet. Here's my values for this resistor and this resistor. We've got to go back to the very original equation. Now nothing about the battery has changed, and nothing about this resistor has changed either. So I can write those in. We have 4.5 ohms, and we have 2 amperes. Here we have 2 amperes and 4 volts. This resistor is unchanged from the previous picture. This 5 ohm resistor on the left. So it is 5 volts and 1 ampere. We can just copy that down again. But now this single resistor here, this 5 ohm resistor, turns into these two in series. Now because they're in series, we know that the currents are the same. So the current of this resistor, which is 1 ampere, that current is the same as these two as well, 1 ampere. Again, we still use our ideas of series and parallel circuits. Now once you know 2 out of the 3, again we solve for the third using Ohm's law. I'll do some scratch work here. We have our voltage is my current, 1 ampere, times my resistance, 2 ohms. That gives me a voltage of 2 volts. I'll do some scratch work down here. My voltage is 1 ampere for the current, times 3 ohms for the resistance. And that gives me a voltage of 3 volts. So now we've solved for the voltage, the current, and the resistance at each part of the circuit, the battery, and each resistor along the way. Again, we're going to combine resistors until they're all series or all parallel. We solve that circuit, and then we work backwards. It still is that a series circuit, the I's are the same, the currents are the same. And for a parallel circuit, the V's or voltages are the same.